In 2017, the universe sent us something strange. At first, it appeared as nothing more than a faint streak captured on a telescope in Hawaii. So faint, so ordinary, that no one could have predicted the storm of questions it would unleash. It didn't shine brightly. It didn't glow with the signature tail of a comet. It wasn't accompanied by a halo of dust or ice. It was just a flicker of light moving across the sky. But hidden inside that flicker was an impossibility. The astronomers who found it didn't know it yet, but they had just spotted the first confirmed object from another star system to ever pass through our solar system. A visitor from the deep, ancient darkness between suns. An interstellar wanderer older than our species, older than Earth, perhaps older than our sun itself. The moment humanity discovered it, it was already leaving. It was named Oumuamua, a Hawaiian word meaning scout, or more poetically, a messenger sent from afar. A name that felt less like a label and more like a warning. From its first detection to its disappearance, the world had just weeks to observe it, and every new detail made it stranger. Some scientists said it was a rock, others insisted it was a shard of something larger. A few, braver or perhaps more reckless, suggested it might be something built, a relic, a machine, a probe, a messenger. No one could agree. And that disagreement continues today. This is the story of the object that defied our expectations, the object that refused to behave, the object that accelerated away from us with no explanation, an object that forced humanity to confront a question we were never prepared to answer. What exactly was Oumuamua? And more importantly, is it truly gone? Welcome back to Beyond Space. Where we explore the universe one mind-blowing idea at a time. The arrival. On October 19th, 2017, astronomer Rob Werrick at the Haleakala Observatory in Hawaii noticed something odd. It moved too fast, far too fast, to belong to us. Objects tied to the sun's gravity follow predictable paths. Their speeds make sense. Comets wander in long, elliptical orbits. Asteroids drift lazily between Mars and Jupiter. Nothing in our solar system moves with reckless urgency. But this object wasn't behaving. It wasn't looping. It wasn't slowing. It wasn't bound to the sun at all. It was barreling through our planetary neighborhood at nearly 200,000 miles per hour, on a trajectory that made no sense. A hyperbolic orbit, something that doesn't loop around the sun, but instead swings past it once, before disappearing into interstellar space forever. Its speed was the first sign. Its shape was the second. Its motion was the third, and perhaps the most disturbing. Immediately, astronomers scrambled to collect every possible observation. But the universe had played a cruel trick. By the time telescopes locked on, the object was already racing away from us. The window to study it was shrinking by the hour. Even so, the first measurements painted a picture unlike anything we had ever seen. Oumuamua wasn't round like most asteroids. It wasn't fluffy like most comets. It reflected sunlight in pulses, almost like a lighthouse, suggesting a long, thin shape tumbling chaotically through space. Some estimates said it could be 10 times longer than it was wide, an aspect ratio never seen in nature. Was it a cigar, a needle, a flat shard like a cosmic pancake? The truth was buried in flickers of light too faint to resolve. We were watching a ghost disappearing into the dark. Soon, scientists noticed something else. Something that changed everything. The impossible acceleration. When an object passes close to the sun, gravity takes over. It speeds up as it falls inward, then slows as it climbs away. That's the rule. That's the physics. Oumuamua broke the rule. As it left the inner solar system, it began to accelerate, just slightly, but undeniably, a few meters per second. Enough that its path shifted away from what gravity alone could explain. Objects don't just accelerate without a cause. Something must push them. Comets accelerate when jets of gas explode from their surface, tiny rocket engines that nudge them through space. But comets also have tails. They heat up near the sun and shed dust and ice that glows in infrared light. NASA's Spitzer Space Telescope focused on Oumuamua, searching for even the faintest whisper of heat or dust. It found nothing. No tail, no jets, no heat, no signs of outgassing. But the acceleration was real. If something was pushing Oumuamua, it was invisible. This was the moment speculation transformed into obsession. Something was wrong with this object. Fundamentally wrong. It didn't behave like anything in our solar system. It didn't move like a natural body. It didn't look like one. And it didn't follow the rules. The universe had brought us something that shouldn't exist, and then it took it away. The theories. Scientists hate mysteries. They will argue, model, debate, fight, and occasionally invent entirely new categories of objects to explain the unexplainable. Oumuamua was no exception. In the months that followed, dozens of theories emerged, some rational, some creative, some bordering on science fiction. Theory 1. The exotic comet. The first idea was the simplest. Maybe it was outgassing, but in a way we'd never seen. Maybe Oumuamua was made of hydrogen ice, so pure and so volatile that sunlight would boil it off without producing dust or heat detectable from Earth. Hydrogen is almost invisible. Hydrogen outgassing could explain the acceleration. Hydrogen ice could survive in deep space, at least in theory. But there were problems. Hydrogen ice evaporates incredibly easily, too easily. By the time Oumuamua reached our solar system, a hydrogen iceberg should have boiled away billions of years ago. The only way this theory works is if Oumuamua formed in the coldest regions of space, far colder than any known star-forming area. That would make it a ghost from the bleakest, darkest places in the universe, shards from a region colder than any we've ever observed. Possible? Maybe. Likely? Not really. Theory 2. The nitrogen shard. Another theory suggested it was a chunk of frozen nitrogen, like the surface of Pluto, knocked off a distant exoplanet. Nitrogen would evaporate quietly, producing enough thrust to nudge the object while staying invisible to our instruments. But this model faced a problem too. To produce one Oumuamua, an entire class of exoplanets would need to be shedding nitrogen shards constantly, at rates that defy our understanding of planetary formation. In other words, it required too much coincidence. Theory 3. The fractal dust bunny. A more exotic idea proposed that Oumuamua was extraordinarily porous, like a cosmic dust bunny, so lightweight that even sunlight could push it, like a leaf caught in a breeze. But that structure would have been too fragile to survive interstellar space. Radiation, impacts, and collisions would have destroyed it long before arrival. This idea faded quickly. Theory 4. The light sail. Then came the most controversial theory. Dr. Avi Loeb of Harvard suggested that Oumuamua might be a light sail, a thin sheet of material propelled by starlight itself. Something like the solar sails we're experimenting with here on Earth. A structure so thin and reflective that the pressure of sunlight could push it, explaining the acceleration without gas or jets. The rotation could be explained. The shape could be explained. The acceleration could be explained. If true, it wouldn't be natural. It would be designed. The scientific community reacted with a mix of fascination and resistance. Some insisted it was irresponsible to jump to such conclusions. Others argued that dismissing the possibility was equally unscientific. In the end, the truth remained frustratingly out of reach. The object was gone. The data was limited. The mystery endured. The pattern emerges. Years after Oumuamua vanished into the dark, another revelation shook the community. It wasn't alone. Astronomers studying small near-Earth asteroids noticed that a handful of them also experienced slight, unexplained accelerations. Not as dramatic as Oumuamua's, nothing that defied physics entirely, but enough to raise eyebrows. Could these be examples of the same phenomenon? Natural objects behaving in ways we didn't understand? Or were we seeing hints of a broader pattern, one too subtle to identify before Oumuamua forced us to look? One of these objects, 1998 KY-26, became the focus of intense study. In the coming years, the Japanese Hayabusa 2 spacecraft will fly past it. If it displays even a trace of the same unexplained motion, it could reveal a hidden class of dark comets, objects that outgas in ways we can't detect. Or it could reveal something stranger, something that forces us to rethink not only Oumuamua, but the entire architecture of our solar system. We wait, and we watch. The chase. Humanity is not a species that accepts unanswered questions, especially ones that challenge our place in the universe. So naturally, a question emerged. Could we catch it? A group of engineers and astrophysicists formed Project Lyra, a mission concept designed to chase Oumuamua into interstellar space. The plan was audacious: a gravitational slingshot around Earth, Venus, and Jupiter, combined with a near sunburn that would accelerate a probe to unprecedented speeds. The probe would leave in the 2030s. It would travel for nearly 2 decades. If everything went perfectly, it could intercept Oumuamua around 2048. Even then, the chances of finding it are slim. It is small, it is dark. It is tumbling through the void with no beacon or signal. The search would be like finding a single grain of sand drifting in the ocean at night, without a light. But the payoff is enormous. If the probe caught it, if it got even a single close-up image, we could answer questions that have haunted us for years. Was it natural? Was it artificial? Was it a message? Or was it merely one of countless objects drifting between stars, unnoticed for billions of years? The mission is still theoretical, but the dream remains alive. The departure. Today, Oumuamua is billions of kilometers away, farther with every passing moment, heading toward the constellation Pegasus. It moves silently, it sends no signals, it leaves no trail. But it leaves us with questions. Why did it accelerate? Why was it shaped so strangely? Why did it reflect so much sunlight? Why did it behave like nothing we've seen before? And perhaps the most haunting question of all, was it alone? Some scientists believe interstellar objects like Oumuamua pass through our solar system every few years. We simply lacked the technology to detect them. Now, with improved surveys, we may see more. And if we do, we may finally learn whether Oumuamua was unique or just the first of many. But for now, it remains a solitary messenger disappearing into the night. A reminder that the universe is larger, stranger, and more alive with mysteries than we ever imagined. The legacy. Oumuamua changed us, not because we understood it, but because we didn't. It forced astronomers to confront the unknown. It inspired debates that shaped new missions. It sparked curiosity in millions of people around the world. It made us look outward, not just with telescopes, but with imagination. For the first time, humanity watched an object from another star pass through our home. We watched it come, we watched it go, and we watched the questions follow behind it like a shadow. Maybe one day we'll catch up to it. Maybe we'll discover more like it. Maybe one will slow down. Maybe one will arrive intentionally. Or maybe this was the universe reminding us of something ancient, that the space between stars is not empty, that wanderers cross the cosmic ocean more often than we think, and that sometimes those wanderers look back, whether natural or artificial, message or accident. Oumuamua left us with a single, haunting truth. We are not isolated. We are part of a galaxy filled with unknown travelers, unknown worlds, unknown civilizations, unknown mysteries. And some of those mysteries occasionally find their way to our doorstep. Oumuamua may never reveal its secrets. It may drift forever in silence. But its visit marked a turning point, a moment when we realized that our solar system is not a closed system, that the universe is watching, that we are part of something much larger. This was the first interstellar visitor in human history, but it will not be the last. Humanity's story is barely beginning, and the universe is only now starting to speak. This is beyond space, and the mystery has only just begun.